Hello everyone, welcome back. This is Dr. Rhonda Kofeld, and we're going to continue our discussion of radioactivity and nuclear chemistry. In this section, we're going to talk about writing nuclear equations and whether they are an emission reaction or an electron capture. So, capture means that the particle on the left of the arrow and you're adding it to the reactants, okay, because you're capturing it with the reactants. Emission is going to be the product side, okay, and it's going to be because you have subtracted that from your original nuclide. And so it'll be like plus over the arrow or minus over the arrow there, which will indicate capture and emission. And I'm just showing you these different ways because sometimes you see them, the shorthand is different. You could also see A as in your parent nuclide, X and Y, where X would be what's captured, and then comma, and then what's emitted, and then the product, okay? So A plus the X gives you Y plus B. So again, you just sometimes see this in shorthand in different ways, or you may see it like this in certain ways, where they would say you are capturing an alpha particle, etc. So obviously these are reactions. So we're going to use nuclear equations to describe them. And so atomic numbers and mass numbers are conserved in the nuclear equation. That is, that you must have the same number of mass numbers and same number of atomic numbers on both sides of the arrow. And so you have to conserve matter. And this is how you determine the identity of the daughter nuclide, is because when you know the mode of decay, you're going to figure out what you're going to have left over. And the example here is that you have 238 mass number and 92 atomic number on the bottom. You are emitting a helium, otherwise known as an alpha particle, right? Could write that either way. All right, since we're doing that, we have two atomic of the atomic numbers already. So this one has to be 2 less, so that 90 plus 2 equals 92. So you now have 92 on both sides. The 238, you have 4, so you have to add 234. So that's how you figure out what your top number and your bottom number are on your daughter nuclide, because they have to balance. Okay, so let's do one here. This says write the nuclear equation for the alpha decay of radium 224. So let's look at this. So you've got, so 224 means that's the mass number. If you look on the periodic table, you'll see that that is element number 88. So that's its number. And then it is going to decay, which means it's giving off an alpha particle, right, which is the same as a helium nucleus. So you could write helium if you wanted to. And then what is this going to be? All right, so what I've got to do, so I've got 88 down here. I've already got 2 here. So 2 plus 86 will give me 88. So the bottom number is going to be 86. All right, then I've got, on the top number, I've got 224. Over here I've got 4. So what plus 4 gives me 224? That would be 220. 220, and then I have to look and see what is atomic number 86, and that is radon. Okay, so all I did was make sure, and then I go back and say 86 plus 2 is 88, and 220 plus 4 is 224, and making sure that both sides are balanced. And I gave you a simple one, polonium to polonium-216 to practice. So these are just different types of things. Okay, these are decays, and so we're going to look at these decays. All right, so write the nuclear equation for the beta decay in BK249. All right, so you got BK249. So I'm going to have to look up and see what that is, and that is 97 atomic number. All right, and then that is going to go to, and this is a product because it's decay, right? So a beta decay is going to be an electron, basically. Right, it has no mass, it has a charge of -1. So I've got to then come over here, and so now this is a -1, all right? So I have to have what plus -1 equals 97, okay? Or what minus 1 equals 97. So this is going to have to be 98 minus 1 equals 97. So this one's going to be 98 on the bottom, and then 249, and this is 0. So 249 will stay the same, but it becomes californium. Okay, why? Because this changed. Positron emission of O15. Oxygen. Okay, oxygen is going to emit a positron, right, which is the positive electron. And so I've got +1 over here, so I need what +1 equals 7, equals 8. So this is 7. And the 15 stays the same because the top one is a 0. And so we just turned oxygen into nitrogen. It's pretty cool how this works. All right, electron capture in I11. When we capture it, what does that mean? It means we're going to be adding it to whatever our reactant is. And so this is I111. I'm capturing it. So, and I'm going to need to see what that is going to turn into. So that's I111, and it's number 53. All right, and so 53 minus 1 is 52. So this one over here is going to have 52, and there's no change in the top number because that's a 0, and so that's tellurium. So really, once you get the hang of this, it's really not that difficult, right? All right, then I've got plenty of practice for you, and that's it for part 2.